Photoelectric sensors are classified as through beam, reflective, diffuse, and diffuse with background suppression. The through beam sensors have a transmitter at one end and a receiver at the other end, so they'll have the longest range and are going to be the most accurate. But they're also going to cost more because you have twice the electronics and twice the cabling. Reflective photoelectric sensors shoot a beam at a reflector, so one sensor head acts as both the transmitter and the receiver, which makes them less expensive, but also means they have a shorter range and they'll be a little less accurate. While the through beam and reflective sensors are looking for an interruption of the beam, diffuse photoelectric sensors actually look for the object to reflect the beam. This is great for those situations where you don't have access to the far side of the object. The downside of this is it's heavily dependent on the reflectivity of the object passing by, has a shorter detection distance, and is less reliable. Background activity can also produce false readings with this kind of sensor, which is where diffuse with background suppression comes in. There are a number of different ways these work, but one of the more popular methods is a sensor with two receivers built in. The transmitter sends energy out, the beam bounces off the target, and hits one of the receivers. When the object isn't present, the energy bounces back at a different angle, so most of the beam hits the other receiver, telling the sensor that this is not the object we want. These background suppression sensors have about the same range and are about the same cost as a regular diffuse sensor, but they perform better in many applications. Fiber optic photoelectric sensors are basically the same animal as regular photoelectric sensors. The main difference is the optics are separate from the electronics. In this through beam sensor example, you can see the two optics heads, which feed back to the sensor electronics through these fiber optic cables. Here's a reflective sensor head where both optics are in one head. Again, it's the same photoelectric sensor. The optics have simply been remoted from the electronics. These sensors even come with a special tool for cutting the fiber optic cables. You can get a feel for just how small these things are when I hold them right next to the regular photoelectric sensors. As you can see, these are great for squeezing into small, tight installations where you can't fit traditional sensors. They're also great when you have an environment that might mess with the electronics, like high heat or electronic interference, things like that. Because with these, you can put the electronics out of the way and only expose these passive optics to the hostile environment. Of course, the larger heads give you the greatest range, out to a couple meters, which is comparable with the regular photoelectric sensors. And since the optics are so small, that means the beam is going to be small, which means you can detect smaller objects. As you can see, there are a number of very definite advantages to these fiber optic photoelectric sensors. Fuse sensor is normally light on, since its output is on when its own light source is reflected from a target. Reflective and through beam sensors are normally dark on, since the output is active when the light beam is blocked. Some sensors can be configured to either light on or dark on mode of operation. Diffuse sensor range is dependent on the reflectivity of the target. In some cases, a dark object may reflect light better than a light-colored object. Diffuse sensors are specified by the distance at which they detect white cardstock. Photoelectric sensors come in different shapes and materials, from plastic to stainless steel, suitable for washdown applications. Just pick the one that works for your application, connect it to your PLC, and you're ready to go.